Hello everyone, I remain your tutor Mr. Life Changer. I in this video is the last series of heat capacity, heat energy, latent heat and all of that. We needed to do this. It's important. The calculation is important. That is why I am doing this. Okay, so so here we are going to have start with number 29. Very important. In the previous video I told you guys something about latent heat. The latent heat is the heat involved during phase change, and during that change there is no change in temperature. Okay, so we have just two questions here, and let us do that quickly. Now this one says calculate the heat energy required to convert 200 grams of ice at 0 degrees Celsius to steam at 100 degrees Celsius. And we are given the heat capacity of ice, we are given the latent heat of fusion of ice, we are given the specific heat capacity of water, and latent heat of vaporization. Now you're going to wonder, what do we do here? Remember that the ice was first of all at minus 10 degrees Celsius. Okay, now ice cannot melt at minus 10 degrees Celsius, cannot. Okay, so it has to, when you heat this, the temperature will increase until it gets to ice at 0 degrees Celsius. So minus 10 degrees Celsius has to increase to 0 degrees Celsius before the ice starts melting. So at 0 degrees Celsius, the ice now begins to melt. Are you seeing that? So there is a process of melting from ice to water, and during that process of melting, the temperature will not change. That conversion, that point where ice is converted directly to water, temperature will not change. Okay, then from this 0 degrees Celsius, it can increase to water also at 100 degrees Celsius. You see that? So from 0 to 100, once it becomes water, it increases to 100. But that's not where we are to stop. It says to steam, to steam. So that means at 100 degrees Celsius, if you keep heating it, all the water will vaporize to steam. But amazingly, at that same temperature, 100 degrees Celsius, at that same temperature. Okay, 100 degrees Celsius. Very, very important. So you can see the transformation. It starts by an increase in temperature here, which is MC theta. Then once it gets to 0 degrees Celsius, it melts. That is ML, but in this case now latent heat of fusion. Now from water, once it finishes melting to water at 0 degrees Celsius and you keep heating, the temperature increases to 100 degrees Celsius. That increase in temperature makes it MC theta. Okay, then at 100 degrees Celsius, for it to convert to steam, that period there is no temperature change. So here is ML, but MLV. So you can see all the energy conversion. So the total energy will be MC theta plus MLF plus MC theta, then plus MLV. Kindly note this. This is how to go about this. Okay, so here the mass remains the same. Of course, the mass is 200 grams, which is 0.2 times specific heat capacity of ice is 2100. This one is for ice, this one is for water. Don't forget, the temperature change of ice is from 0 to 10, so the temperature change is 10. Now plus mass of the mass remains the same, 0.2 is the same substance, times latent heat of fusion is 336000. Now plus the mass remains the same, 0.2, specific capacity of water, now this is water, is 4200, times the temperature change of water. Water changed from 0 to 100, so the temperature change is 100. Then plus mass again, the same, 0.2 times latent heat of vaporization, which is 2,260,000. Okay, so let's calculate them. This is quite long though. Of course, you shouldn't expect a question like this in objective, but wouldn't be bad for you to know. They wouldn't get to this point. This first one is 420 plus the second one 336000 multiplied by 0.2. The second one is 67200 plus the third one 0.2 times 4200 times 100. This one is 84,000. Then plus 2,260,123 times 0.2. This is 452,000. So let us add this. So we have 420 plus 67,200 plus 84,000 plus 452,000. Okay, my answer here, I hope I didn't make any mistake somewhere, is 603,620. So I think my mistake here should be here. This shouldn't be 420, this should be 4,200. So let me do that again. So 4,200 plus 67,200 plus 84,000 plus 452,000, 607,400. 607,400. Okay, that is it here. Interesting, right? So let's see the last question here. It says a refrigerator extracts heat from 1.5 kilogram of water at 20 degrees Celsius. To convert it entirely to ice at -5 degrees Celsius, how much heat must be removed? You can see that from 20 degrees Celsius to -1.5. How do you achieve that? First of all, this is not heating, this is cooling. So first of all, you had water at 20 degrees Celsius. The water reduced to, the temperature will reduce to 0 degrees Celsius as you keep cooling, in the refrigerator. Then from water at 0 degrees Celsius, as you keep cooling, it becomes ice at 0 degrees Celsius. Remember, during phase change, temperature does not change. Then ice at 0 degrees Celsius now becomes ice at -5 degrees Celsius. You see that? So once it gets to this, it can now change. But that period where it is changing from one to another, water to ice, the temperature can never change, or ice to water, or water to steam, or steam to water. Don't forget that. Temperature will not change. The heat involved here, since there is a change in temperature, is MC theta. The heat involved here, there is no change in temperature, is ML, but here latent heat of fusion. And the heat involved here, since there is a temperature change, is MC theta. Remember that the mass remains the same across. So the total heat now is going to be MC theta plus MLF plus another MC theta. The only difference is that this is water and while this is ice. You get that? So the mass of water in this case is 1.5 kg. Specific heat capacity is 4,200. The temperature change of water from 20 to 0 is 20. Plus the mass is the same 1.5. Latent heat of fusion is 336,000. Then plot mass of ice is the same 1.5. Specific heat capacity of ice is 2,100. Then times temperature change of ice from 0 to 5 is 5. When you subtract 0 minus -5 is 5. You see? So let's calculate this quickly. So we're going to have 1.5 times 4,200 times 20. So this is 126,000 plus 1.5 times 336,000, and this is 504,000. Then plus 1.5 times 2,100 times 5, this is 15,750. So if we add that up, 126,000 plus 504,000, then plus 15,750, that is giving us 645,750 joules. That is the answer, 645,750 joules. So the answer to this question is B and not A. So I believe that this is helpful. Now, but I want to say this, that in an exam scenario, especially if it's an objective case, you're not going to see something like this. You could see how do you convert 20 degrees Celsius of water, okay, to steam at 100 degrees Celsius. It's going to be as simple as this. So if you want to do this conversion, if you start with water at 20 degrees Celsius, it must get to water at 100 degrees Celsius first. Then before water now changes to steam at that same temperature, remember, once it's changing state, the temperature does not change. So here you're going to have MC theta and here you're going to have ML. In most objective case, this is what you have. Most times you're going to have H equal to MC theta plus ML. It's only maybe for those of you writing theories that you could have cases where it is longer than this. Thank you very much. Don't forget to like the video, subscribe, share, to friends. This is going to help a lot. Have a wonderful day. Bye bye.